Okay, we're going to look at practice C, which is the work kinetic energy theorem. And we are going to work problem number 3. Okay, so problem number 3 says a 2.1 times 10 to the 3 kilogram car starts from rest. Oh no, what does that mean, starts from rest? Equations from chapter 2. At the top of a driveway that is sloped at an angle of 20 degrees. With the horizontal. An average friction force 4.0 times 10 to the 3 Newton impedes the car's motion, so the car's speed at the bottom of the driveway, VF, is equal to 3.8 meters per second. What is the length of the driveway? Okay, so this one problem, this combines, the rest of the homework isn't this hard. I obviously picked the most difficult problem. This combines equations and things that we learned in Chapter 2, Chapter 3, and Chapter 4, all in one problem. Okay? So where do I start? Well, I want to find how far this goes. And when I'm looking at that, I need to think about, well, what did I learn in this chapter that talks about how I would find this x? Okay? Well, one of the things that I learned is that work is equal to FD. And this D is really Fx. So work is equal to Fx. And I know work is also equal to the change in kinetic energy. So if I wanted to find this, how far this goes, I need to find the work done, and I need to find this force, and then I could find x. So how do we begin? We always begin with the free body diagram. So the free body diagram shows all our forces. I'm going to use my sign convention as down the incline is positive. This is the hardest type of problem you could ever do with this, just to let you know. Okay? So opposite the direction of motion is the frictional force, which is parallel to the surfaces in contact. The force of weight acts straight down, and the normal force acts perpendicular to the surfaces in contact. And this angle here is 20 degrees. So now I'm going to take my weight, and some of you got this wrong on the test, so there's nothing wrong with a little bit more practice. And remember, my components are perpendicular to one another, and they replace this. So what I like to do is I like to do it to the side. Here's my weight, F of G, and the components are perpendicular. This is a 90-degree angle. This is FGY, this is FGX, and this angle here is 20 degrees. So when I find the components of this, first I have to find F of G. So F of G is equal to mg, which is equal to 2.1 times 10 to the 3 kilograms times 9.8 meters per second squared. So F of G ends up being it's a big number. 2.1 times 10 to the 4 newtons. So FGY is equal to FG cosine of 20. Why is it cosine of 20? Because it's adjacent to that angle. So FGY ends up being 1.9 times 10 to the 4, and FGX is equal to FG sine of 20, which comes out to be 7 times 10 to the 3. I redraw this. F of F, F of N, those stay the same. It's moving this way. Remember, my sign convention goes like this. This is my X and this is my Y. And now I have FGY and FGX. So what do I do? So I need to find the net force in order to find how far this slides down. So I'm going to sum forces horizontally. Summation of F of X is equal to MA. So now I'm going to look at, well, what forces are acting on this? So when I look at my free body diagram, I have FGX, which is positive, minus F of F. Okay? And remember, this means F net. Now, do I need to solve for the acceleration? No. I just need to know that this is equal to my F net, because F net is what I need to go back and find that distance. And again, I know that work is equal to the change in the kinetic energy. Work is equal to FD, which would be KEF minus KEI. So this is my net force. So F net times D is equal to KEF. So all I really need from here is what this F net is. So my F net is going to be FGX, which is, it's actually 7 times 10 to the 3 minus 4 times 10 to the 3. So F net is equal to 3 times 10 to the 3. So then I take this equation, F net times how far it goes is equal to KEF, which is 1/2 mvf squared, and I'm solving for how far it goes. So D is equal to 1/2 mvf squared divided by F net. So it's equal to 1/2 2.1 times 10 to the 3 divided by 3.0 times 10 to the 3. So this comes out to be 5 meters. Well, it starts from rest, so the initial velocity is 0. They gave you VF in the problem. They gave me VF, oh, I forgot to write it on here, was 3.8 meters per second squared. So the VF was given, the VI was 0. Now, first looking at this problem, it looks extremely complicated because we're combining things. But as you practice and do these, and this again is the hardest type problem that we would do in this chapter, like this.